All right. Just making sure we're getting started here. Good to go?
Yeah, we're good to go.
Clearly, we're all over the technical game here. So we have a more limited group of us tonight. People in data science are busy out doing consulting, saving the world. I don't know. So are we really saving the world? Maybe we are some days, but most days I don't think I'm doing that at LinkedIn, but you never know. Well, welcome everybody to another episode with a more limited panel of data science office hours. Tonight we're gonna plan to make this a little shorter. We have a number of questions and topics that we want to touch on, but when we have a more limited panel, we're able to get more discussion in just with the two of us, and so I think we're going to kick it off there. I don't know if I think it's of interest to hear about when significant things happen in different weeks. So Fabio, I don't know if you want to tell us a little bit about, you had posted on LinkedIn earlier this week about a new adventure. So do you want to share a little bit about what that adventure looks like?
Yeah, so I recently changed jobs. I started this Monday, and it's a really exciting thing for me because this is a really big store. It's called OXXO, OXXO, and I'm working there as a principal data scientist. They're creating the area right now, and I'm trying to build a team, to create the standards and all these different things. So it's a really fun thing because we're starting from scratch, and also it's the biggest commodity store here in Mexico. So they have over 16,000 stores. So it's a really big challenge here.
Okay, awesome. So you are 3 days into employment. Yeah. So have you solved all of the problems that you need to at the company?
So of course. It's going to take maybe 1 year at least.
1 year, come on. I'm going to give you 6 months. If you haven't solved everything in 6 months, then,
Yeah.
Cool. Well, congratulations on that. That's awesome to hear that you are getting the chance to move into more of like a principal role. So I'm sure people that are listening will probably also decide that, oh, maybe he makes hiring decisions and we're going to flood him with applications about jobs that we want. So that may be something that happens. Will you be building out a team, you mentioned?
Yeah. I'm not sure how big it's going to be. I have to decide. I'm in the process of knowing the business. And This is something we all should do when starting a new job in data science. Take a few weeks or maybe 1 month to understand what's the business you're working in. Because I'll say this 100 times. I'm a physicist. I worked in a bank, and now I'm working for a retail store. So everything's different.
I mean, that's the path you pretty much intended to carve out from day one, right? When you started studying physics, you were like, I'm going to work in
Yep, of course. When I did my first quantum mechanics exam, I really thought of working in retail. That was my
that's awesome.
My thought all the time.
That's all right. So I think we have a number of questions that we want to dive into a little bit. Given the more limited scope in terms of time, I think we'll try to give somewhat compressed answers, and we'll see. We can move through as many questions as we can. For people that are listening and watching, also understand that some of these questions are certainly too deep to just answer within 5 minutes, and they might serve as the basis for posts that we make or future episodes for data science office hours. So keep those things in mind, that when we ask these questions, while our answers might be somewhat short, the issues and topics are probably much deeper than we can dive into just in this short period. So I want to kick off this question, and I don't think we'll have a full time to be able to talk about using all of the different algorithms available to us in machine learning. But when you think about doing machine learning and choosing the best algorithm to use, Fabio, I'll let you take it first before I jump into it. But how do you quantify what best means? Like, of course, we have different like numerical measures, but if you have to say this is the best model, what does that typically mean for you?
All right. So first, you need to understand what's the problem, and I think for choosing an algorithm, I think that may not be as hard as understanding how to solve a problem with machine learning or data science. I think the first step may be trying to change the problem into a full question. And when you have a full question with a thing you want to solve, then you can think, oh, is this a classification problem? Is this a supervised or unsupervised problem? Is this a computer vision problem? And when you have the scope of what are you going to do, what I always do is I start out with a baseline, maybe something really naive, and some people will be maybe they can come as a surprise, but a lot of things that are in production right now for a lot of companies are really naive things. Like, yeah, we use the mean here and we use the median here, and for the last 10 years we've been using this minus this, and that's it. So the first thing I take into account is what is existing right now for this kind of model. And what I do is I have that baseline. I measure how distant it is from the right question, and then I really go and dig in. I always try to run different algorithms. If it's a classification algorithm, I will always start with logistic regression. Then I'll go to maybe a tree model, and maybe then go further. So for choosing what's the best, maybe it will depend on the needs of the business, because when you go and think that they want to to fully understand what's going on under the hood in your model, maybe you don't want to run a really hard model that you are not able to explain. And sometimes a model that's not that complex can be really accurate. So maybe you can go and try out some metrics, and of course you validate the model, you do the cross validation and everything, you fit your parameters. And if it always start with a simple model, you don't need to start with deep learning and the convnets. That's maybe the last solution you have to think of. And if a simple model is working and you try out some different ones, maybe if you can just go there and stay there.
Cool. I think you walk through like what a very typical process looks like for deciding on, a best model. I think what I've learned in the past few years is that best is probably defined by the work that model does for the business, right? And so I'm speaking specifically from a business perspective here, and not necessarily from like an academic paper perspective. But at the end of the day, the model needs to do the most work it can for the business. And so there's this balance between, of course, you can look at all these different metrics, numerical metrics we have to say what the best model is. But at the end of the day, the business side wants something that is going to deliver them results that they're going to be able to see ROI from. And so I think about, okay, what models are going to provide the best return on investment? And you can think about the time, like all of the investment that goes into building a model. But a big part of this is also saying, how interpretable is the model at the end of the day? Because there's certainly the model performance and how good the classification is. But in a lot of my experience, so much of the value that the business sees from any model that you build, they don't really care. Like if I say the words random forest to them or gradient boosted trees or whatever, like they don't care. They don't necessarily know what I'm talking about. This is gibberish. Instead, it's saying, all right, because they build this model in this particular way, I now understand what the key variables are for this business problem that I have. And so I think there's two healthy perspectives to keep. One, in terms of defining best as like a numerical measure, a traditional way that we think about model building. But there's also the very important perspective of saying, what work is it doing for the business, and is it best from the business perspective? So I think ROI is another key metric that I think is really worthwhile to consider.
Yeah, and I think that's a good point. considering that it's different to do machine learning for research and for the business. I
Mm-hmm.
mean, we can spend 2 years working on a paper to improve 0.1% a metric. And people, I mean, they're doing that in research and academics. And of course, that's really important if you are doing research. But if you're working for a business, you will not want to spend 4 months trying to improve 5% of accuracy or precision of your model. And that's not something they will really care. I mean, you need something that is working, that will return the I mean, for them the best answer you can get, and that's it.
Yeah. I think, again, this is one of those things that we could dig into in
Yeah.
so much depth. But just in terms of, moving the conversation along a little bit, there's also the question of when you're in an interview setting, right? So you could have read 10 books on machine learning, have a really good understanding of the algorithms, but then maybe in an interview setting, you have 1 hour to prove that you know your stuff, right? And so you have that 1 hour. And so I think the question that I've put forth is, so how do you show what you know in that hour? What are the key things that you look for? So I think a question that you and I can answer is, if you're interviewing somebody, right, how do you judge whether they have the machine learning knowledge that you think they need to have?
All right. I think that will also will depend on the level of seniority of the person being interviewed, because not the same maybe for a really junior data scientist to fully understand what's going on under the hoods.
Right.
And I think being an expert in math, or knowing knowing more about eigenvalues and all of those different things, I mean, that's not really understanding machine learning. I mean, of course, that will be understanding machine learning in a research field or in an academia. But the thing I will measure is how they use machine learning to solve a problem, and that's what I will ask. It's like, can you explain a situation where you use this kind of model? Maybe, I don't know, a decision tree to solve a problem in your business, and how did you start? I mean, what did you do, or why did you or why would you choose this over this kind of different algorithms? And I don't think that being an expert in which are the parameters of the algorithm is really important, because you have the documentation out there, and we are not working in a closed environment, and that you need to understand, oh yeah, I need to put 10 in max iter here, because no, I think that's not quite important as really understanding why when to apply a model, and when a model or an algorithm will work, if it will work with only numerical variables or categorical variables. What will you do if you have both of them in a data set, and how can you transform the data set to be able to run the kind of algorithm? I think that's more important for me to measure.
Right. I think that adds a lot to, like, it just spurs my thinking a little bit. What I was going to mention when I was first writing this question is, I don't always get the chance to do this, but in an interview setting, if I have a little bit of time left at the end of like a machine learning like time period, I actually ask people, I'm like, so tell me about a time that you messed up building a model, right? Like, whether you overfit the model to an insane degree and you only found out later, or you tried to do something you tried to do something building a random forest model and it just did not work in any way, shape, or form. And so I asked them, like, what mistakes have you made in trying to build a model? Because I think, to me, especially in this field, we don't necessarily learn anything until we've done something wrong. Like, seeing how it works is great, because there's so many tutorials that show you, hey, look, this works beautifully. This is fitting together. It produces this really nice result in the end. But they don't show you the 1,000 times that you screwed something up, right? So I think for people that are listening, consider that you should also think about not only the times where things have gone well, but what are the times where you think something did not go well and you learned from it in terms of trying to build a model. And that could be anything. I mean, you could even focus on something as simple as like linear regression and say that, okay, I was building this. This has happened to me many times where you get so used to building it and you sometimes forget to evaluate some of the core assumptions that something like linear regression has. And then you figure out later that you pay for that, right? If you don't necessarily validate those assumptions. So if you're prepping for an interview and you're getting ready for this, don't just talk about things when they work very well, but also try to be aware of what do things look like when they don't work very well, like, and how do you deal with that? So,
Yep.
um,
So I think will we have time? I mean, if there are no questions for people out there, we can continue with these questions. But if you have questions, make sure to type them in the chat area, or we will continue doing this kind of inside Q&A.
yeah. Yeah. So I think the like as I was generating these questions today, and pulling in Q&As from past sessions and also the things that you and I get on and all of us get on LinkedIn regularly, there's a question that I find hard to answer sometimes for myself is hiring people in data science is hard. Companies, there are a lot of reports out there that say like there's a huge demand for data scientists. We have to hire this many data scientists by 2020. Yet at the same time, job candidates all the time are saying, I send in tons of applications, I get no responses, I get nothing. So I'm curious about what your perspective is. Why do you think that is? Where do you think this gap exists? Do you think the companies are being super picky? Do you think the candidates are missing key things? I mean, I think this is an open discussion because it's something that I think a lot of people consider and they're frustrated by it.
Yeah, and that's something I really get a lot on LinkedIn, man. I've been applying to 100 jobs and I have nothing. So first of all, this is not only for data science. There's a lot of people applying for different kind of jobs and getting nothing too. So I think right now these kind of platforms like LinkedIn are increasing the number of applications a company can get and actually go through. So what if you get, I mean, 10,000 applications in 1 month? That happens because, I mean, if you have the premium version of LinkedIn, you can see how many applicants are there for each company, and it's insane.
Yeah.
I think it's really hard to go to 100. But what if you have 10,000 and that's something happening? So in data science, apart from that, I really think that one of the first problems we have is a lot of a lot of the big companies are really picky, and I understand that, and I understand why, and they've been doing that for 10 years, 15 years, and it's going well for them. So it's not easy to go there, and there's two other sides of for small companies. One of the issues is a lot of them have no idea what data science is, and they're trying to look for something that they don't understand why they want. So in the process, they're maybe not getting a good filter for people. Maybe they don't understand the requirement you need to have to be a data scientist, or maybe they're trying to hire you in a process that will go for a software engineer. It's not the same for data science. And I think the other part of that is a lot of companies are actually being really picky because they think that if Google is doing this, why wouldn't I do this? So, and I've been rejected a lot of times, for small companies that think they're Google, and it's not the same. It's not the same process, and you're not the same company. sometimes there only one senior data scientist. Why not have, I mean, why won't you hire junior data scientists to understand the business with you, hand by hand, step by step? Maybe that's better than hiring someone from Facebook or from Google or from LinkedIn to go there and do all of the job for you. So I think those are my three takes on this question, and that's it.
Yeah. So I think I have a sometimes harder perspective. I haven't necessarily been on the hiring side as much. Um, but I do know, I think some of what you touched on is when people are hiring in this space, they tend to behave as other companies behave. So they look for very similar things. They tend to value the same skill set, and they try to. And what I see companies doing is defining themselves in the same way that Google does or that Facebook does. And so if you create one image of what data science is, that's going to also result in your hiring process only accepting people who are essentially superstars and have a track record of being superstars. But that's a really silly way to approach it, because for smaller companies that are just getting started, they're going to have to make the right hire that will probably become a superstar down the road.
Yeah.
They're probably not going to pull in somebody who has been at Google or been at Facebook. And you know what? That's completely okay. You get so much value from people. I mean, just because somebody's been at a top tier company does not necessarily mean that they're going to be right for your business. And so my response right now, I realize, is turning into a partial like criticism of, of the hiring process, but I also understand why the hiring process is like it is, because the companies, they don't know what else to do. They want to go off of an image of like, what does it mean to be good in data science? And so they follow the companies that they know are good in data science, and they try to create themselves and behave in the same way. So I think this gap that we're seeing, like for people listening, it's not because there's a lack of skill coming. I think it's a lack. I think the companies haven't yet quite figured out what they want. And because they haven't figured out, or I should say, if they have figured out what they want, sometimes they have, how do I put it? They are shooting too high. They're aiming for people who have a very specific background and skill set. And what I'm starting to see is companies are having to adjust their expectations. They're saying, all right, if we really want to make an effective data science team, we're going to have to reconsider our assumptions that we make.
Yeah.
And I know I was talking like in a maybe previous conversation with Sarah, who can't join us tonight. She'll be back a couple weeks from now, hopefully. But she mentioned like domain knowledge versus technical knowledge, right? So when it comes to like when you think about a skill set that you're trying to hire for, some companies specifically care about the technical preparation that somebody has. Do they know SQL? Do they know Python or R? Other companies are much more concerned with saying, all right, does this person have a marketing background? Do they have a sales background? And some companies are much like, how did you put it? Saying they want it all. They want to hire someone who's perfect in sales, who has 10 years of experience in a programming language that hasn't existed for 10 years. And so I think that's these gaps and this frustration are very real. And I put a lot of the burden for right now on companies, and it's not because they're intentionally doing it. It's because they don't necessarily know better. And I think they're starting to learn about adjusting expectations and finding the right candidates to get into these jobs. But for people that are listening, like this is a really important issue, and it's one that's not going away. So you think about how would you, it's like Fabio, I think adding on to this. So let's say that you do bring in, let's say you decide, all right, instead of going after these top tier data scientists who have had 10 years of experience in a particular area, Instead, we're going to bring in more junior candidates. So some things that you can do there, like invest in training, right? Like, you know that you're going to have to, like, you might be able to get people for a lower salary, but you know you're going to have to invest significantly in training. What are some other things that you think companies can do to move away from this paradigm of we have to hire the superstars and instead start saying, let's hire people who don't have the pedigrees of like the Googles and the Facebooks?
Yeah, and I think this comes together with the different kind of tools we have right now. I think we are on the path or transforming the software for data science world in an easy way to work with things. I mean, every day I see amazing libraries come out with for R, for Python, for different kind of languages, and it's easier to do data science day by day. And I think maybe 5 years ago, you will need someone with a lot of experience to do all of these kind of things in Java, really weird Java things that people did back there to do data science. But right now, I think that's easier. And I think you're gonna maybe you're gonna spend more money on training these people, but they will be training with a focus, and that's different because maybe this guy is the best in machine learning, but maybe I need someone who understands my business to be able to do something for me. So if someone else expend money, or he or she is spend money for training him or herself, maybe that kind of training is not is not the best for my business. So I think it will be interesting to see a lot of different companies trying to maybe take a bet here for this kind of junior people that are really they're passionate people. I've talked with them. They want to learn. They want to be there. And you're gonna be able to see them grow, and they're gonna be loyal to you. I think you will not. I mean, I think it's easier for a data scientist who knows a lot to go from company to company that someone who grow or grew in your company to go out there and search for something different. So I think that the the turnover will be less if we really focus on those kind of candidates. And if you see on Google or Facebook or all of these big companies, the turnover is really small. This people is only there for 1 year, 1 year and a half.
Mm-hmm.
And I think this is the thing. They just go there like a trampoline to go to create their own business. So maybe if you spend a little more money on this on maybe 5 junior data scientists and you train them, maybe in the end you'll get more value.
Yeah, I think that makes a lot of sense. Like, and so that investment in training is something that has to be accounted for and budgeted for, though, right? Just because you might get somebody for a lower salary doesn't mean that you are going to have a lower overall expenditure to the business. And I think that's a perspective that can be very valuable for companies that are trying to grow what they offer in data science.
Yeah.
So I think in terms of one last question, cap it at half an hour. I'm curious from your perspective, because I think we all probably have our own answers. What makes someone stand out to you in this field? Like when you meet somebody who's in data science and you get to know their different skill sets and what they're good at, what makes you say, wow, this person is different and is someone I would like to work with or have on my team?
All right. So I think that answer changed for me this last year because I came from academia. Maybe 1 year and a half ago, I will answer this question by saying the person who knows more about the inside of things and who's the best or the paper stuff will be the best. But now I'm actually thinking, and I've met people who's amazing at telling stories with data. And I think being able to write or maybe talk and make people understand these hard things we're doing, and I think that's amazing. And people who's trying to solve problems and they're actually doing it, and in the end they're explaining these things they found for themselves, for the team, and for the business. I think that's the people are, I maybe doing more for data science right now in the world. And I think this, and I think we're seeing more and more of this with this kind of different blogs, like towards data science and Katie Nuggets and Data Science Central. And I think right now I do two things every day. I Before I only read papers and books, and right now I'm actually reading a lot of blogs. I mean, I'm a blog addict right now. I always go on Medium, on Katie Nuggets, on all of these different on LinkedIn all day to find people who's actually doing amazing things, trying to explain these different concepts. So I think for me, someone who's able to take all of these weird and hard things and put them in simple words to help their company or the field is doing an amazing job.
Yeah. I think my answer to this question has probably evolved over time too. Um, it probably started out when I was doing a business analytics program where I was just blown away by people who were very technically strong, right? You say like, wow, they can program, they can do these things incredibly efficiently. And that was more of, I think, when I was learning, right? I was really deep in the learning phase of tools, technologies, etc. But then I think that changed a little bit when I jumped into the private sector, when you start thinking about, okay, what value do you deliver at the end of the day? And when I see, and I shouldn't say that like, because technical expertise is still hard to find, like really deep technical expertise is not easy to find. But what really makes me do a double take when I hear somebody who not only has the technical expertise, but is able to really hold in mind what the business problem is, right? Like they their programming and the things they build are brilliant, but they're brilliant with the purpose of helping the business in a particular way. And understanding the business in a way that then a lot, like, when you're building, like, let's say you are building production level code, some people can get very caught up in that code and the depth of the code, and they make it as elaborate as possible. But someone else might have a simpler approach. It might not look as elegant, but it has a much more major impact on the business. And that for me makes somebody stand out. And so it's not just this technical expertise. It is this desire and willingness to understand the business as well as they can, to try to decide where their technical expertise can be of the most use, right? Like
I think that's the best definition I've ever heard of someone being good in data science.
Yeah, and it's a hard thing. It's a hard thing though, right? Like, and it wasn't until I saw it happen where I see examples of it, I'm like, wow, this person is who I would like to be when I grow up in data science, right? Like I still
Yeah.
I mean, there are people at LinkedIn, like people on my team, and I look at them and I'm like, they are what I like aspire to be in this field. Like they have that whole package. And it's something that, if you set your sights on that and you say, not only do I want to be really good technically, but I want to get in and understand a business to the degree where I can make a major impact, I think that starts to be where you say, all right, these are like the rock star data scientists. It's not that they know one programming language better than everybody else. It's not that they know statistics better than everybody else. It's that they have this skill set that allows them to make this huge impact on the business. So that for me is like what defines somebody as.
No, and I think the best thing that people can take out of this when you're talking is we have all of these people in mind that we admire, and they also have these people they admire, and that is a never-ending chain. So don't think that they think they're the best, and that's it. They also admire people. They're also wanting to be better every time, and we're learning all the time. Don't think that, yeah, I see someone that's maybe the best. When I'm like him, I'm done. No, this is science is a never ending process, and we're always learning and improving ourselves and improving the things we're doing. So don't think that because we have these maybe positions in data science or we're talking here, we're more than anyone. We're people learning all the time, trying to do our best, and we admire people that admire people that admires people, and that's it.
Yeah, and yeah, sorry, lost my train of thought. But that typically means that it's probably a good time to cut off the cut off the podcast for tonight. But I think this is a really useful format with just two of us.
There's some questions out there in the chat. I don't know if we have time to maybe go to one or two of them.
Cool. I think let's just take one for now. I think with just two of us, I want to try to keep it somewhat constrained until we have a full group next week.
One of them is really weird. I don't understand it. Is how do I get a hold of Eric Weber IRL?
In real life? Oh no. I don't know if I should give my address away here. That might be problematic for a lot of reasons. LinkedIn, is that real life? Does LinkedIn count as real life? I guess we will for now. That is a weird question.
I think this is a good question. So maybe we can take this and that's it. So this is in a real is asked by SM3 friends. I don't know. In a real world seldom do we have data that can be looked in a simple form. Is it a good idea to mathematically understand the distribution of it, or just try different model to try to come out with a solution? So I think the question here is if you really need to go deeper into mathematics, or maybe just come up with a solution and that's it. What will you say?
I don't think I have a good answer like immediately. So this is what I've learned from teaching, is that when you don't have a good answer, you like kick it to the other person, but there are only two of us. So give me a minute to think about that. I don't know if you have like an immediate thought, but
I think my immediate thought maybe is if you really understand the problem, I think is okay to go deeper. But if you don't fully understand what you're doing, maybe just trying a solution and then improving that solution step by step could make you understand the problem better. And this is something that has happened to me in the past. Maybe I just try a really simple baseline or linear regression model, and then this is what I'm trying to do, and this is why I didn't do it correctly. So maybe trying a real simple or naive solution can get you a better fully understanding or the big picture of the one that you're trying to solve, and then you can go deeper and improve the solution.
Yeah, I mean, I think what you mentioned as far as establishing a baseline is really key, right? And that baseline may come from the simplest model that you can build. The baseline may come from what the existing results are for a business, right? Like the baseline may be, all right, your model has to beat this or it's not worthwhile to the business. But I think there's a lot to be said for like having that baseline and then understanding as you iterate through different versions of a model and you tweak different things, understanding, okay, why is it beating the baseline so much? Or why is it dropping back? In some cases, it might do worse than the baseline. So what is it about that? I think that contributes to, like I've seen really complicated models end up performing worse than the baseline. But that doesn't mean you should just throw away the model. It means that you should understand what about the model was making it perform so badly. Like, was it picking up on a very specific signal in the data and overfitting to it, which I think is a pretty common thing to happen. But I think, like you said, start from a baseline, vet new models against it, but don't just throw it out if it doesn't perform well. Try to understand why it doesn't perform well.
Yeah. And I mean, and that happens. Sometimes the baseline is better than a deep neural net. I mean, that's really weird, but it has happened to me that a simple baseline with an average is better than a full model. So don't get frustrated in the beginning and try to improve it. All right.
Cool.
So I think we can finish here. There's a lot of questions out there, but maybe we're gonna try to answer them next week.
Yeah.
And thanks you and thanks everyone for being here with us. Of course, you can see this YouTube video afterwards, and maybe send it to your colleagues and friends. So
Yep, share it widely.
Yeah. All right, Eric.
All right.
Thanks a lot.
So much. All right.
Bye bye.
Bye-bye.
Thanks. Bye, guys.